Hi, my name is Brian Liu. I'm in third period of AP Calc AB, and today I will be teaching you the mean value theorem. So what is the mean value theorem? The mean value theorem essentially states that if f of x is continuous on the closed intervals of a to b and differentiable on the open intervals of a to b, then there must be one point c in the closed interval of a to b so that the derivative of c is equal to the slope connecting the endpoints of a and b. Let's say you have a graph with x values of a and b. If it was continuous, it essentially states that you do not have to pick up your pencil to connect from point A to point B, wherever those points lie. This could be in two forms, like this form or this form. If it was differentiable, it would have to be a smooth line, because at the jagged lines, at the sharp turns, f prime of x does not exist because you cannot take the derivative at the points. So let's connect the dots. If you drew a line and it was continuous and differentiable, connecting points A and point B, this would be, and this would be. Now, if you think about it, if you drew the line connecting the points, it's just the slope, yeah? So this is just the change in y over the change in x. So f of b minus f of a over b minus a is equal to the slope. So the mean value theorem essentially states that there is at least one derivative. So I'd say it's around here and around here. So that the slopes of the slopes of c and the slopes connecting points A to point B are the same. You have to remember, whenever you apply the mean value theorem, you have to state beforehand that it is continuous and differentiable before you can use the mean value theorem. Alright, let's do the problem. Let's say f of x is 1,297 plus the third root of x minus 1, and you're given the interval 2 to 9. And the problem states find all c's in interval of 2 to 9 so that f prime of c equals the slope connecting 2 to 9. So this would be f of 9 minus f of 2 over 9 minus 2. So the first thing you're going to want to do is check for a continuity. So here's a helpful tip. In root functions, everything is continuous in their own domains. Since in this expression, nothing would make this expression undefined, the domain would be negative infinity to infinity. So because of this, you know that f of x is continuous on negative infinity to infinity. So by knowing this, we know for sure that the function is continuous from the interval of 2 to 9. So that's a check. Now we need to check if the function is differentiable. So we're going to rewrite f of x as 1,297 plus x minus 1 to the 1/3. So f prime of x would be 0 plus 1/3 times x minus 1 to negative 2/3 times the inside, the derivative of the inside, which would just be 1. So f prime of x equals 1 over 3 x minus 1 to the 2/3 power. So we need to check when this is undefined. So this would be undefined when the denominator equals 0. So 3 times x minus 1 to the 2/3 equals 0. We can rewrite this as x minus 1 equals 0. So x equals 1. By determining this, we know that f of x is differentiable from negative infinity to 1 and 1 to infinity. Since our interval is 2, 9, we can conclude that from the interval 2 to 9, f of x is differentiable. So we can put a check here. So now that we know it's continuous and differentiable, we can apply the mean value theorem. Now that you know the function is both continuous and differentiable, you can solve for it now. So f of 9 minus f of 2 over 9 minus 2 would be 1/7. So by knowing this, 1/7 is the slope connecting the points 2 to 9. So therefore, we would want to set the derivative of f of x to 1/7, because those are all the points in which the x value, the derivative of that specific x value is equal to 1/7. So we can cross multiply and solve it out. So we got x equals 1 plus or minus 7/3 to the 3/2 power. So the interval given to us was 2, 9. So we have to make sure that the x value fits within that interval. 1 minus anything would not be greater than 2. So it would only be 1 plus 7/3 to the 3/2. So that is the one point at quote unquote C, where the derivative of C would be equal to the slope connecting 2 to 9. So that is the answer. Here are some tips on how to apply the mean value theorem correctly and efficiently. So the first thing you're going to want to know is that in root functions, f of x is continuous on their own domains. That will save you a lot of time. It also helps if you use the powers or chain rule when needed as a shortcut instead of doing it the long way. This would save a lot of time as well as eliminate possible calculation errors. There are a lot of mistakes that people can make when using the mean value theorem. First, people do not check if the final answer fits in the given interval. The final answer has to be in the given interval, otherwise it does not answer the question. Another mistake people commonly do is set the slope connecting the endpoints to f of x instead of f prime of x. This would result in a completely incorrect answer. One more mistake includes not checking for continuity or if the function is differentiable before you even try to solve it, because if it's not continuous or differentiable, then you can't use the mean value theorem. Thank you for watching my video and have a great day.